Okay, here we are. This is the fourth and last of the videos that I'm wanting you to look at, where in this one we've talked about the decay of atoms. We've talked about the way in which you can make atoms decay at your command by throwing neutrons at them. And we've talked a little bit about how you might want to control that reaction. And so for this last video, we're going to just simply go through the parts of a nuclear reactor step by step. And so hopefully that will take care of everything you need to know for this entire chapter. So right here we have a picture of a nuclear reactor. Mostly what is always visible when we look at a nuclear reactor are those large smokestacks. They look very menacing. It looks very scary. And for many people, this is a sign of how nuclear reactors are so polluting and dangerous to the environment. What we're going to find out is that what you're looking at is actually possibly one of the most environmentally friendly things that we do to make energy. So kind of an interesting thing going on here. So first, let's just get into the words that we're going to be wanting to know as we go through this. There's a few that you're going to need to know in order to explain everything. The first one being the reactor core. Reactor core is where all the fun happens. That's where we have the actual chain reactions taking place. Inside the reactor core, we're also going to have things such as the fuel rods. That's the rods that contain the atoms, the material that we need. So basically, it's the materials made of the unstable atoms. Typically, this is going to be uranium, but we also have the control rods. Now, you remember from the last video, we can insert some sort of material, these rods, in among the fuel, and this can stop certain neutrons from getting around. It slows down the reaction in a way that I want. I also have something else in there, what's called the moderator. Now, this is going to be almost like the soup, I guess, the material that all of this is going to be contained within. So if you can picture what's going to happen here, we're going to have kind of this soup where inside we're going to put the fuel rods and the control rods, but the soup itself, the liquid itself, will be made out of mostly graphite. And graphite, what it does is going to slow down the speed of the neutrons as they fly around. So it also is going to be part of the process of controlling the speed of my reaction. Second, we're going to be moving from the reactor core to the heat exchanger. This is really the whole point of why we're doing this. We'll get to that. The heat exchanger will be also something that will work with a turbine and a generator. So these words are going to come up when we start talking about this whole thing. So keep a lookout for all that stuff. And hopefully when you're making your notes on this, you can add in those labels as we chug along. So without further ado, let's get started. So I'm just going to draw this. I don't know what this is going to end up looking like. So this might be a big mess, or it might turn out to be looking pretty good. Let's see what happens. So first things first, though, is we're going to have our, let's start way over here at the reactor core. Now the reactor core, this is going to be where everything's going to happen. It's going to be our large containment of the fuel rods, of where the actual reaction happens. So this is going to be a well-protected area. So we're just going to, let me see, I guess I should just make the area now. Let's just see. There's no real shape or anything. I'm just doing stuff here just to give you an idea about the different parts. So when I draw these things, I'm not going to draw them as they actually look. It's just simply, I guess, it's just going to be shapes. A few things might make a little sense, but I'm just going to, let's just say there's my reactor core. Let me see, I'm just going to quickly, make a big wall around my reactor core because I don't want anybody to accidentally get hurt. So I make myself a pretty strong little Let me see, a little strong wall around the whole thing. And just as you saw in the video before, we're going to fill this up with water. So we've got this filled up. Whoops, we've got this filled up with water. And this water becomes really important here. We're actually going to want that water for later. So now we're going to put in also, now while we're at it, let's stick in, we'll just put them in here right now, the fuel rods. So, and these are actually rods. This is how we do it. We stick in our fuel rods into our whole mixture. And let's just label those two. That'll be our fuel rods. And this, of course, as said before, this is our uranium, probably 235, but it could be something else. Like I said, this is a typical material that we use. It might not be a uranium 235. It could be something else. So be a little careful about what I'm saying there. Also, this is all in some sort of material. I'm just going to put this material in here. Let's just I'm going to just put this material here so you can see it. I'm just going to little dots so you can get an idea that there's a material that the fuel rods are inside. And this is what I call the graphite moderator. So if you want to put a note down about what is this for, the idea is that this will help slow down the neutrons. That's the whole point of the graphite moderator. So it's slowing down the neutrons as they run around. And lastly, I got one other thing I got to put in here because there's a lot of stuff happening. I'm going to also put in, let me see, what color will I get? I'll make it brown. I'm going to have these guys, and this is going to be, let me see, I'll fill them in a little bit. And in amongst the fuel rods is these, and they're another set of rods, and you probably already know from the earlier video what these are going to be. Let me see where I can put. I'm gonna put the name over here. These will be the control rods, and the control rods could be made of usually something like boron or cadmium, and they just remember they soak up loose neutrons. So what they do is they don't allow neutrons just to fly around anywhere. And it helps control that chain reaction. Once again, that's all we're trying to do the whole time is control the chain reaction. And I got to mention, don't forget, there's water everywhere. There's water throughout this whole thing. And the water is really important. Water is incredibly important. And let me explain why. And I'll help explain here by putting two little holes in my reactor core. And there's a good reason why I'm doing this. So just so it's clear, I've got two little holes here. Because what I'm doing is I'm actually going to run that water around. Let me just put the water here, and I'm going to run it in a loop. So let's just do this. Whoop. So let's just so you can picture, this is a pipe that's running the water. Let's run the water here. The water is going to go here like this. In fact, hold on now. I'm gonna just make sure you realize what we're doing here. This is really, and maybe I should draw this like this. This is hot water. Now remember what we said about the whole nuclear reaction. We have a lot of energy being produced inside. And so this is heated water from the reaction. So the water inside a reactor core is actually circulating through a set of pipes that lead out of the reactor core and into another area. So this is another area here. Now notice this water doesn't go away. It's the same water in reactor core. It is highly radioactive. So let's just make this clear now. I'm just going to go back to the red for a second. It is highly radioactive. So you don't want it to go anywhere. But what we want, radioactive, what we do want is we want the heat. We don't want the water itself, but we want the heat that is being produced inside here to heat up something else. So what we do is we bring the water over to another area. Let's just put this area right here. Let's just say this is going inside. Let me make a little hole here. Let's just, here, this is kind of neat. We can do that. So it's going in and out of another thing here. Let me just try to make this look a little reasonable here. Okay, it's not going to look beautiful, guys. I'm not at my best here in terms of artistry. We're just going to very quickly draw these things. So I'm just, let's say this is like a big tank. All right, so we're going to make a big tank here, like so. And let's just remember that this is all inside. I'm just going to draw it dotted so you understand that this is all interior. This is not, the pipe is running inside this tank. So what is this tank here? This is actually known as the heat exchanger. This is the heat exchanger. So what's inside this? Why, it's more water. Of course, it's more water inside. This is a whole pile of water here. And this is so that the heat from this radioactive water but very, very hot, highly radioactive water is heating up this water, and this is clean water. Now, I'm going to have to make another pipe over here because there's two holes for this water. This water is clean. It hasn't been in a reactor. So what I'm going to do is I'm going to get, let me see, let's just draw this. Cold water. So this is cold water in. Now you'll notice that most nuclear reactors are going to be located either on the some water or by a lake or something. And this is because they need this cold water. They use the cold water from a nearby pond or lake or river or ocean. And so this water comes in and it will get, let me just try to, it's going to, as it passes by these pipes, oh, that's not a very good, I want a better orange than that. There, that's a little bit better. It's going to start to get a little hot. And so as it passes by, it heats up. It heats up here. And so then when it comes out over here, what I'll do is I will put another pipe in where now I have hot water out. So remember, the whole point of this is that these pipes are incredibly hot, and there's a few other things going on here. I haven't really explained everything, but we by changing the size of the pipes and a few other items, a few other things, I can actually get this to be really, really hot. And so this is actually hot steam. This is not actually even liquid anymore at this point. This is going to be hot steam. So this is incredibly hot water, incredibly hot water. So what comes out here at this point is going to be just simply whoosh, steam like that, coming right out. There we go. So you get the idea. I have hot steam. And then it actually is with pressure, pressurized. So it has a lot of force. It has a lot of force. And the reason why I want that is because then I have here a turbine. Now, the question is what is a turbine? Turbine is actually quite simple. Turbine is simply a wheel. And it's a fancy looking wheel. I mean, it's going to have these little cups in it along the way. So let's just draw the cups. And these cups are, oops, I'm going to mess up my words there, but you get the idea. They're going to capture the steam. So the steam is basically coming through at very high pressure with a great amount of force, and it makes the wheel, I shouldn't draw it like that here. Hang on now. Let's just turn that. Let's take those away for a sec. I should use a different color. I'm going to use, let's say blue. I'll use blue. Okay, so this whole thing is actually going to rotate because the steam is pushing it around and around and around. Okay, so just remember now, just so it's clear, where does the steam go? Let's just bring the steam over here. Steam is still pushing through. So it pushes through, I get all the steam, and then the steam goes away. Now, this is what you see normally in most nuclear power, well, actually all nuclear power facilities. You'll see these giant smokestacks, and it looks very scary, and you think, wow, look at all that smoke coming out. Oh my God, that is so much pollution. And now what you can kind of relax about a little bit is realizing that this actually is just simply, there we go, this is nothing more than water vapor. This is just simply, whoops, let me try black here. This is water vapor. It's just the steam. So steam goes up the smokestacks. So when you look at these large smokestacks at nuclear power facilities, what's kind of interesting is that this is not even smoke. Smoke is actually usually filled with a lot of what's called carcinogens and very dangerous particles that go in the air and make everything dirty. But in a nuclear power plant, this is actually nothing more than hot water, and is perfectly safe and clean. And so it's kind of interesting when you have this idea about nuclear power plants being so dangerous. And there is dangers, of course. There's always the danger of something horrible happening in a nuclear power plant. But some of the things that we think about when we see them is not actually quite true at all. We actually get some very clean waste product coming out of this at the time. Let's go back to the turbine, because that's the last part of why we're doing this. Because the question is, wow, why am I doing all of this? So just think about it. I've got a nuclear reaction, and the whole point of the nuclear reaction was to create heat. This is really all it is doing. And in order to do that, we get this hot water coming through these pipes, and that hot water pipe, which is separated from this other water, this water heats up. We get the cold water from the river that passes by these pipes, and this hot water gets really, really hot, so hot that it becomes hot steam, very strong pressure that makes a turbine move around. And let's just say this turbine now I'm going to connect to let's say a belt. So as it goes around, it makes the belt go around. So this thing's going around, so that means this is going up and this is going down. And this makes another wheel here go around as well. So I've got this nice kind of wheel here going around and around and around. So let's just make that again. We're going to say this is turning around and around like that. And so then we're left with, well, why am I doing that? Now, here's where I'm going to have to just be very, very simple with you. I can't get too detailed. This is actually going to be something that anyone doing Physics 12 is going to find out a lot about. But basically, this is rotating a large, what we would call a large coil. Let me see. So I'm going to just simply say this is a large amount of wire that goes around and around and around and around and around like this. And it goes in between two magnets. Here's my north part of my magnet. Here's my south part of my magnet. And so this coil of wire is connected to the axle of this wheel. So it is also rotating through the magnetic field. Let's just draw the magnetic field. I got, remember, north, south. My magnetic fields go from north to south. And then why would I do this? It is because then this coil will connect over here and make electricity. Electricity Electricity. Sorry, I drew that a little too big there. There we go. That's the whole reason I'm doing this. Okay, so this part up here, this is the turbine, and this would be the electromagnetic generator. I am generating electricity. That's the whole point. This is the whole reason we're doing this, is that we want electricity. And we're basically saying, okay, we're going to start in our reactor core, create hot water. The hot water moves a thing around. The turbine spins, and it makes another part spin that rotates a coil of wire. There's another word for this, just in case you're curious. This is known as this coil of wire is known as a solenoid. That's the name. You're going to use that next year, but for now, just remember this is a solenoid, a bunch of wire wrapped in a big circle, and it turns and turns and turns through a magnetic field. And when it does that, it actually makes, yay, electricity. And this is basically the whole point of a nuclear reactor. And this is what all the parts do. So if you have any questions, of course, this coming week, please ask me if you're not sure about anything I've said. But this is all the parts you need to know. If you were to tell me exactly how a nuclear reactor works, of course, you might want to give a little more detail as to, well, why uranium-235, why control rods, exactly what is a chain reaction. All those things you learned from the earlier videos would also be part of this description. But the parts, the overall parts of a nuclear reactor is basically as you see in front of you now. And that's it. Okay, and that is everything you need to know. These 4 videos on nuclear power. So I hope that helps clear everything up. And good luck. See ya.